Okay, so today, guys, we are going to do a cell project. Rihanna, you are going to do the cilia and flagella, and Katie, you are going to do the ER and the ribosome, since we can't give Katie 2 and you 1. Sound good?
The next morning.
Hey guys, what are you up to?
We're trying to look at this thing up close. I wish you could see it even more closely though. What if we use an electron microscope? Wouldn't that kill it?
Yeah, it probably would, but maybe there's another way we can look even closer.
A few moments later.
Here we go! I'm the endoplasmic reticulum. That's so cool. What do you do? So the rough ER synthesizes proteins and it has ribosomes bound to its surface. What about the smooth ER? And the smooth ER deals with calcium ion storage, detoxifying drugs in liver cells, and synthesizing cell membranes and lipids. That's so cool.
Hi, I'm from Walkerville Elementary, and I'm here to interview you for a cell project. So what are you?
I am cilia and flagella.
Cool. So what do you do in the cell?
Well, the cilia is only found on eukaryotic cells. Basically what the cilia does is that they're like short hair-like appendages, and they vibrate to move around the cell. The flagella is it works for motility for the cell because the rest of the cell is too lazy to do that. So we kind of Uber it around, propel it.
Hi, I'm from Walkerville Elementary, and I'll be interviewing you today for a cell project. So what's your name?
My name's Ribosome.
Okay.
Thanks for asking.
Hi, ribosome. So what are your functions in the cell?
Well, I'm mainly used for protein synthesis, but there are two kinds of me that make different kinds of proteins. So bound ribosomes that stay next to the endoplasmic reticulum, you might have talked to them earlier, they make proteins that are going to go outside the cell, mainly, and free ribosomes make proteins that are going to stay inside the cell. So to make it easier for my students, can you guys describe the relationship between them all?
Hi, I'm the ribosome, the most important part of this relationship. So if we're going to talk about how we're all related, I'm going to talk about bound ribosomes because those are the ones that are attached to the ER. We basically make proteins that are meant to be sent outside of the cell, and they get threaded into the ER and then sent off in transport vesicles.
Okay, so aside from the ribosome explaining our entire relationship for me, the polypeptide chain that the protein creates is threaded into the rough ER, and that gets folded up and can be modified before it buds off and we send it off to the Golgi.
Okay, so after the Golgi, the most important part is the cilia. And basically what the cilia does is they wiggle them out, the little transport vesicles, and they're off on their way.
So basically what I learned from this field trip was that the rough ER synthesizes proteins with the help of the ribosomes, threading and folding polypeptide chains and modifying them before sending them off to the Golgi.
So basically after the very irrelevant ribosome and the very talented endoplasmic reticulum are done with whatever protein or vesicle is going on there, the cilia actually helps to wiggle them out, which I thought was pretty cool. They're very encouraging and they're very motivational speakers.
Hi, I'm another student, definitely not Miss Frizzle. Anyways, what I learned about the ribosome today is that they can be free or bound, meaning they can be found in the cytoplasm or the rough ER. They're very important in protein synthesis because they translate mRNA enough to make it into a peptide chain. And then it either gets put into the ER because of transport vesicle and then goes to the Golgi apparatus, or just goes from the Golgi straight from the ribosome in the cytoplasm.
Cruising on down Main Street, you're relaxed and feeling good. Next thing that you know, you'll see it. Octopus in the neighborhood, surfing on a sine wave, swinging through the stars. Take a left at Julie Teston, take your second right past Mars on the magic school bus. Alligator nostril, climb on the magic school bus. Spank a plankton too, on our magic school bus.
Hey guys, what are you up to?
We're trying to look at this thing up close. I wish you could see it even more closely though. What if we use an electron microscope? Wouldn't that kill it?
Yeah, it probably would, but maybe there's another way we can look even closer.